here, Gestalt principle, which is one of the really famous, like the guy who developed this kind of examples. So like a proximity, similarity, and cruiser. I mean, using this keyword, I highly encourage you to Google it. There's a lot of information here. Let me do this actually. We can do this together. See, image. So this is sort of like a concept, how we dealing with the visual language, what is like a best way or worst way. I mean, there's a sort of like domain, they talk about this kind of things. We need to learn something from them. And Burton's visual design space is also very famous like concept or principle the designer need to understand, okay? So for example, yeah, this Burton's visual attribute, he's the guy. Thank you. And Burton's visual attribute. So there's some like a nice diagram. Yeah, very straightforward. We have a mark and point, a line and area for the mapping, right? And then so we can like think about the position as point as a position, right? Size and the gray value, and texture, color, orientation, and shape. This is like a one-on-one or sometimes most important like guideline that we can repeatedly remind while making our own visualization for mapping, correct, right? So, I mean, this is a really good guideline to keep thinking what is the best in a visual language while against our data that we want to visualizing right now, right? So this is like talks about like a most efficient way, most less efficient way. This is about like quantitative data. Yeah, position, length, slope, angle, area makes sense, right? But what if we have like ordinal data or nominal data, just like color, there's no order, correct, right? So maybe there's a lot of experimentation and knowledge or principle, as I said. So this kind of individual, this kind of small concept is actually change your fundamental or like the impact of your visualization. So this is actually my experience. It's a really important material. So mark, point, line, area. And as one of my research, clustering point is one of the way to, as I said, like a filter the data, right? Raw data. So think about we have a vertices on the mesh or point data on the map, right? So the clustering is a good technique, even for the machine learning stuff, to draw some line between some two different things. So there's a very traditional way to make the point cluster, like a grid-based cluster things. But you know what? Based on their purpose, we need to. I think this is really important to pick the methodology. So grid-based clustering sometimes is good, but sometimes it's no good for the interaction things. So I invented like my mouthful name, like collision-based dynamic graph method. So it allows us to interact the point while the cluster the data at the same time. You can actually play with the data on the map. So this is the idea. And then the implementation goes to the story map. So if you guys want to experience, there's an app on the internet, so you can access it. So I'm just, as a developer, as a engineer, I can tell you it's like basically, build connectivity based on the collision. So for example, we have a point, they collide each other. And then we can think about, oh, they are one group and one group, right? And then based on the collision, I create the graph, yeah. However, think about, we have point, yeah, a lot of point, they are like, how can I say? We have a point like this, yeah. They all collide each other, yeah. Then they become like one point because they simply connect each other, yeah. So in this case, we need a more the other special sort of a process, like a recursive checking process based on our resolution, right here, so that we can tessellate the graph and then post-process, and then at the end of this process, and then I push this data to the renderer to draw something. Yeah, this is all the logical operation, and yeah, whenever you change the zoom level, and we need to execute. Otherwise, we are good to go because we already processed the data. So on the real-time rendering process, what we need to do is just draw the result, yeah, which is a more optimized way. Here, the other sort of concept, like a principle of graphical, integrity. Yeah, I think this kind of a keyword and examples is inside our brain, actually. How we dealing with the bar chart, for example. Can you see this? The number is actually different. Yeah, yeah, number is different, but graphically they look similar. So the press, the press is they actually dealing with a lot of let's say, I don't know, I don't want to say, but anyhow, the newspaper or some the political magazine, they actually play with the bar chart or pie chart by this kind of graphical integrity, which is no good. For the visualization specialist, we need to be careful, like a light factor, as I said, like an ink ratio. We need to avoid the chart jump. This is all the well-defined keyword. Yeah. So for example, there's a link, I guess, the light factor here. Yeah. Again, this is a well-defined area. So what we need to do is learn something from that area, right? So this is how we calculate the light factor. Yeah. Yeah. So there's a full of insight. Yeah. And the data ink ratio. This is also very interesting. So according to this article, the data ink ratio. Obviously, that one, the one below is the more straightforward and more clear way against this bar chart. There's some principle. Yeah. So I think that this is a really good time. Even for me. Sometimes I'm trying to remember. And sometimes I compare my result with this kind of the principle or the integrity. Yeah, so this is a really good filter to revisit, because the data visualization is not one time or linear process. It's more like an iterative process. Yeah, make some system visualizing, and then we create the other pipeline to tweak the visualization again, and then we can, basically fitting the process to revealing the result out of data. Yeah, this is all about like visualization, iterative process. In this iterative process, we need to keep in mind this kind of a principle, which is actually, small thing can change a lot. So, junk chart is an article. I highly recommend you guys to visit in graphical integrate. I found a nice material. See, yeah. In this pie graph, I felt like, what is this? String is bigger than collisions, but the ink ratio, it has a more ink. So as a visual effect, people perceive, oh, that one's a little bit bigger than that one. But actually, the number, this one is higher than this one, but it has a three-dimensional, so it has an unnecessary ink down there. So this kind of light factor or some principle is there, so we just take advantage of some of the measure system to measure our visualization. Sometimes 3D visualization is really bad for the data, I think. So I think simple is always straightforward, and yeah, I don't know, it depends on the data, but again, there's a link. I'll encourage you guys to just read the article, and then based on the keyword, you can create your own search on the web, Googling things. And also, I give you guys the other interesting, sort of brainstorming page. Yeah, 45 ways to communicate two quantities. Yeah. So we have two quantities, right? 75 and 37. There's different types of representation, the compelling two different entities here. See, we have the reflected icon or human 10 unit, decimal, bar, line graph, percentage bar, yeah, proportion, or by pie chart, yeah. and focal area. Yeah, interesting, right? There's this many way, you know, to just compare two different values. So I think that this kind of brainstorming is also become important, because sometimes if you really focus on your work, you couldn't see. So we need to some place to, you know, take a look at our work, a little bit different perspective. So I sometimes visit this website and then just take a look at it with the mindfulness of my data. So I mean, just the brainstorming purpose, which is also good reference for you guys. I recommend to visit. And this is one of the famous, you know, the visualization, let's say, called Nightingale morality. You know what? So, I mean, there's a more clear or useful information describing what is this. But as far as I know, this is describe the war, the UK took the war against Russia, and then there's actually the diagram that Nightingale did is revealing an insight. Previously, people thought about during the war, you know, in the battle, yeah, maybe people can die, right? Because battle, right? But the visualization, it turns out no, there's an outbreak. So the people dying in the battle is very small, again, compared to the people who die because of the outbreak disease. Yeah. So according to this, after this visualization, they have some like a different, you know, let's say policy or whatever, like a clean things during the war. I don't know. But keep in mind, you know, most important thing is that how we review the result from the data. First of all, we need to fully, you know, deploy our domain knowledge, right? This is most important things. The reason Nightingale can draw this diagram is because Nightingale is a nurse, right? He has a full of the idea about the human and disease, right? So, and also we need to analysis the data, right? And then we keep tweak the analysis. Is it on the right track or not? It's like an iterative process. But at the end of the visualization, at the end of the day, at the end of your visualization work, we need to speak with the data because, you know, we are dealing with data, yeah. And also we need to talk visualizing with the insight. Yeah, this is I don't know. This is sort of my last word to you guys in terms of the visualization in the lecture series.